We've all heard of 3D printing from the media. Printers that use materials like plastic, metal, nylon, and many other materials. But I thought 3D printers used just ink. 3D printing, or additive manufacturing, is a process of making a three-dimensional solid object of virtually any shape from a digital model. Printing technology has been around since the 1980s. The first 3D printer was made by Chuck Hull in 1984 and used a technique called stereolithography. By the early 2000s, printers had become commercially available. The main use for 3D printing technology lies with visual prototyping. However, there are many more uses pertaining to the industries of architecture, construction, industrial design, automotive, aerospace, jewelry, eyewear, and many, many more fields. Printers can make shoe designs, furniture, wax castings for making jewelry, as well as automotive and aviation industries using 3D printers to make parts. Physicians can use 3D printing to make prosthetics or print out body parts from CT scans. Baking companies can print out food designs. Electronic companies can print out electrical parts, and the list just keeps going. A 3D printer needs a digital file. It can get its file from a 3D modeling program or a 3D scanner, which would then be broken up into hundreds of different layers, sent to the 3D printer, where the 3D printer will then start printing the object, layer by layer. Computer-aided design is one of the many tools used by engineers and designers. Many 3D designing softwares have their own file type, but all of them take the universal files OBJ, STL, POI, etc. Stereolithography, SLA, invented by Charles Hull in 1984. It concentrates a beam of ultraviolet light focused onto the surface of a vat filled with liquid photocurable resin.
Stereolithography is a process that translates CAD designs into solid objects through a combination of laser, photochemistry, and software technologies. With 3D Systems Stereolithography Apparatus, or SLA, CAD data of the product design is first sliced into very thin cross-sections. A laser beam of ultraviolet light is then focused onto the surface of a vat of liquid photopolymer. The laser traces a cross-section of the part, turning a thin layer of the liquid plastic to solid. The cross-section is lowered and recoated with liquid photopolymer, and the laser traces the next slice on top of the previous one. The process continues, layer by layer, until the part is complete. Unattended, the SLA works around the clock. Without tooling, machining, or cutting, a three-dimensional part is built in a matter of hours.
Fused Deposition Modeling, FDM. It was invented in the late 1980s by Scott Crumb and extrude a stream of melted thermoplastic material in layers that fuse together and harden.
What we have here is called Fused Deposition Modeling, or FDM. It's an additive fabrication process that takes filament like this. It's run through our system through a heated element and through a chip, and it lays the plastic down layer by layer. Now the layers that it's following is a model that was derived from a 3D CAD file. We take that file and slice that layer by layer to create tool paths, and then the tips on the machine that you're seeing follows those tool paths, laying it down layer by layer, and the table drops, giving you your Z height on that. And so this is a soluble core material that our machines produce. And what we do is we print out the core, and it's filament wound. In this case, it's with carbon fiber, and it's put into an autoclave, cured at 250 degrees, and then this is washed out in a detergent solution, leaving you with the end-use carbon fiber duct. So this is a MRI head coil that was done for a healthcare company, and this is all done out of polycarbonate. The reason why is you can image through polycarbonate without any interference on there. So this is low volume production. This is not an application where they need tens of thousands of them. So the FDM process fits this application perfectly for low volume manufacturing. You do not need the required tooling for production on this. So these come right out of the machine. Just some minor finishing to them and painting, and it is the end-use part that is used in hospitals. Now this is just a application. This is a prototyping application from the Toro company. That what they did is they prototyped it to their designs first to make sure it was going to be functionally correct and operate or behave as designed. And you can see this is the end model. Once they approved the design, they went into production with obviously an injection molded piece.
Selective Laser Sintering, SLS. variances in technology include PolyJet photopolymer, which uses much like an inkjet printer, but then dries with UV light. Selective laser melting, SLM, which is much like the SLS system but fully melts powder. The electron beam melting, EBM, uses electron beam instead of a UV laser. The laminated object manufacturing, LOM, uses layers of adhesive-coated paper, plastic, or metal that laminates are glued together, then cut with a knife or laser cutter. Solidoodle. Cubify cube. RepRap Mendel. MakerBot Replicator 2. Stratasys Mojo. And so many more.
Soon, you may be able to create a kidney with a copy machine. How would you like to download a coffee table? Or at least a digital model of a coffee table that you could customize any way you like so it fit perfectly in your living room, and then you just print it out. I'm not talking about a picture of a coffee table. I'm talking about an actual physical, three-dimensional object that lives in your living room. Well, it's all possible. It's the world of 3D printing, and it's going to change everything. It'll redefine the way we think about innovation, design, manufacturing, distribution, everything about buying and selling tangible goods from here to Mars. Simply put, 3D printing is the process of making three-dimensional solid objects out of ones and zeros from a digital file. 3D printers bridge the gap between the digital and physical worlds. It uses very thin layers of plastic measuring just a few microns, as thin as a sheet of copy paper, to build an object from the bottom up. This is additive manufacturing. It creates a new item by adding only what is needed, unlike other forms of manufacturing where the excess is carved, cut, or melted away, leaving a ton of waste. And 3D printing isn't limited to plastics. Already you can print stuff in glass, metal, food, organs. I'm not talking about the musical instrument, I'm talking about human tissue. I kid you not, a couple of years ago there was a guy who demonstrated he could print human kidneys using living cells as ink. We're talking about the ability to create transplant organs with a 3D printer. And this isn't the future we're talking about right now. I mean, we've come a long way from the 1980s when a bunch of do-it-yourself nuts decided to kickstart 3D printing. Today, you and I, people who have real jobs, we could actually go out and buy one of these things for like $1,000. Forbes estimates that it'll be a $5 billion industry by the year 2020. And as these printers become more popular, the price comes down, which means that consumers like me and you can afford to buy one ourselves or have a friend print one out for us. Once we get to the point where we can print circuitry directly, you print one printer that prints another printer, and it's game over. We're talking limitless customization. You could even scan your entire body and print out your own action figure, or in my case, an inaction figure. NASA's using 3D printers to make repairs on space equipment. They use a process called selective laser melting, or SLM, that they use to create a nickel alloy to repair everything like, well, the J2 rocket engine. I mean, this is the promise of 3D printing. We can make our lives as customized as we want, print any object you can imagine, and have it in your hands in just a matter of hours. And in the immediate future, it could mean that astronauts are able to print out repair parts for spacecraft or space stations, which is pretty important when you're months away from a rescue mission. I mean, imagine what it would have been like if Apollo 13 had had a 3D printer on board. But then we wouldn't have had Tom Hanks in space.